Hello everyone, welcome to my channel Cloud and Data with Kaushik. So we already discussed two algorithms, that is logistic regression and linear regression in the previous session, and now we are going to focus on the decision tree model, because the task we have to create, you can see this is the task, decision tree and random forest. So actually we have to create the four machine learning models over here, and we have already covered logistic regression and linear regression. Now we have to create the decision tree and random forest. Okay, so uh, you can see that in the machine learning algorithm and build a decision tree model for, we have required one dependent variable, that is your churn, and your independent variable, that is tenure. So I already added this code because the process is same, just you have to uh, change your models. Okay, but rest of the things, most rest of the things, you can say that is mostly equal. Okay, that is no any changes, only you have to change the model. So that is the reason I have added this code, and so you can understand. So first we have to take the columns. So you can see customer churn dot columns, and you can get all the columns, and that I've discussed earlier also, customer churn dot columns, and you have to get all the columns name, and your independent variable is tenure and your dependent variable is your churn. But my question is that when we can use that decision tree model and when we can use the other model, right? So decision tree model, what is the use case that when we use that decision tree model? Because mm, if you see the decision, I already added the concept over here, and then we come to the point to your that you can say 1 minute. Yes, so decision tree model. So the I can say that the decision tree you can use that depends on various factors, right? So it can related to your specific machine learning problem here. So interpretability, that is one question. So decision trees are generally more interpretable compared to random forest. We have two models we have to create, right? One is decision tree, another is random forest. So as per interpretability, decision tree models are generally more interpretable compared to random forest. If understanding and explaining the decision making process is crucial, a single decision tree might be preferred. Okay, and one other point that I can say, that resource efficiency. So decision trees are very faster to train, and it require less computational resources compared to random forest. So resource computation, the rendering process, that is very less if you compare this model to the random forest. Okay, so if you are working with small data set, if your data set is small, right, or you have resource constraint, then a decision tree your may be a more suitable choice in compared to the random forest. So 2 points that I have told: interpretability and resource efficiency. And you can say I already added these lines, and overfitting concept. So decision trees are prone to overfitting. So especially if you they are very deep, and regularization technique or limiting the maximum depth can help mitigate this. But it's an important consideration. So we have to choose over random forest like decision tree when we have to choose. That is one of the major point, that overfitting concern. Next, that feature importance. If you need to understand the importance of individual features in your model, then decision tree would be a right choice for you for the feature importance, right? So that is the reason we have choice the decision tree. So if anybody asks you that question, that when we have to choose the decision tree, that 4 points majorly you can say, that interpretability, resource efficiency, overfitting concern, and feature importance. So let's move towards our code. Just I have added these lines for understanding purpose. So here you can say our dependent variable is churn and independent variable is tenure. So we have to target column, that is my is churn, right? So we have to provide the decision tree model in order to establish that prediction, right? So we have this, you can see I already extract two values, X that is customer churn, sorry, tenure, and Y I have added customer churn, and that is the churn column. And you have to print that X and its type, and also I have print Y and its type. So you can see the different values are coming over the Y column, right? And your X value, that is your tenure. Now, in order to create decision tree model, you need decision tree classifier. Okay, so you have to import sklearn from sklearn.tree, and you have to import decision tree classifier. And you can also search, if you go, and you can also search, you can go and in the Google you can search that your decision tree classifier sklearn. Okay, so you may probably get this link, sklearn.tree decision tree classifier. You can go over there and you can explore. There are all the details they have given, and there are different kind of parameters they have also used. That is the things I've not discussed over here. I'm just focusing the project, how what is the task and how we have to implement the task. If you want to explore more, and you can check this official website link, and also some kind of coding they have given. You can explore these things, and there are parameters, criterion, splitter, max depth. So everything is given. So I have to import. You have to import the decision tree classifier, and I am more interested to see the plot tree, means graphical use interface of the decision tree. How decision tree looks like graphically. Okay. So in order to in order to create the decision tree model, you need to import the decision tree classifier, and you need to import that plot tree, these two things. When then you have to initialize your model. You can see I have initialized. Now we have to create the decision tree classifier instance. So you have to create the instance, the same process that I have used in the logistic regression, I have used in the linear regression. The same process you have to take. So as any name you can take for the variable that I have taken my decision tree model. So you have to take in the decision tree and your decision tree classifier. This model you have to take, and now you have to split the data into 80 into 20. Means 80% data should be your training purpose, and 20% data that should be goes to your testing purpose. And your random state is 0. Okay, most of the concept are same. You can see I don't have to do any other things. That is the reason I am not coding this thing, because these are simple things and that I have already added. So the main aim for this project, that is the end to end, everything is there. You can do the data manipulation, you have to do data visualization. So everything is done. That is the reason we have to create it. Now let's focus on that part. So you have train, and you can also take the shape xtrain.shape and xtest.shape, and you can see the data of rows and column for your training data and your testing data. And y train, you can also see your training data. When y test, you can also see your testing data. And now we have to feed the model on top of the training data. So you have to write my decision tree model. This is my model. You can say my decision tree model dot feed and you have the X10 and you have Y10. Now we have fit the model on top of the training data. So your decision tree classifier model you have created, and now you can see I have stored this prediction that predict I have to do in the test data. So X test, and I have to add this my Y pred variable. All the process are same, all the things are same. Only you have to change the model. Taking means whenever you do the decision tree, then you have to take the decision tree classifier. Okay, and Y pred. So you can see the decision tree classifier prediction is okay. And now the last questions for the decision tree side, that is build the confusion matrix and calculate the accuracy. Okay, so we have to create the confusion matrix, that is also your Y test and Y pred. So these two variables you have to take Y test. So already we have created the Y X test, Y test, X test, Y test, and these two things are different: your testing purpose and your prediction purpose. Okay. So you also get that you also calculate manually, okay, the accuracy score. So confusion matrix, you can see 965 plus 87, this value, and also you can divide 965, 87, 281 and 76. So actual accuracy score you can get. Okay, so 0.74 percentage. Okay, and also if same thing, if we have to check na accuracy score, so you have to check that Y test and Y pred. These two values you have to provide, and you can see the same result you can get, same value, right? 0.75%, and here you also get 0.75 percentage, right? So now we can just call the accuracy score function 0.75, and I am testing. We already done the test train and test split. 80% data should be in the training data, and 20% data we kept for the test site, right? And in entire, I can say in entire data science life cycle, most crucial part is the data processing part, and it also depends on your problem statement. And if you are if your dependent variable is continuous variable, and that is numerical, and if you want multiple categories, like, then you will go with multiple categories, then you go the decision tree or random forest classifier. So multi-class and categorical problem, multi-class and categorical problem, then you can go the decision tree. But that depends on the business problem that you can say. And everything I have coded over here. Now I have the separate videos that where I have to I have discussed all that models, when you have to use, what is the score, and when you have to use decision tree. That not an issue, but here only focus on the task, how we have to perform this task, whatever is given to that projects. And we have created, you can see the accuracy score, and here you have to import your, I am more interested to see the plot, and you can see I have created this plot tree. You have to import the plot tree, and you have to recognize your decision tree model. In my case, this is my model, and I have created this plot. You can see one plot that the graphically you can understand, right, how the decision tree looks like. because actual problem we are just calculating the numbers, but how it looks like, that is also important graphically. So Decesion Tree has that visualization part that you can also use, that we can use plot tree, and you have use your model, and you can see the model. And I have also created one subset of how if I implement the Decesion Tree in the iris data set, right? Then it's how it looks like, and it does not link to my current projects, my customer churn analysis. That is just an example in order to understand how the data set looks like. So you can see I have import sklearn, import data set, and that I have imported from sklearn, and you have to load your data, like from the data set you have load the iris data, and you can see this is the iris data set. And same thing, right? You can check train test split. I have used train test split and iris dot data, iris dot target, and this is your x, this is your y you have to provide. And here also I have kept 20% for the testing size and 80% for the training data, and here random state is 0. Okay, and initialize the model, the Decesion Tree classifier model. You have to create this model, and next the process is same, model dot feed. You have to feed your model with the training data, that is x train and y train. And now I have to interested to see the plot area. So this is the one small example that I have created on the iris database to understand how the Decesion Tree looks like. So every features you have to provide iris dot features name. You have to provide, you have to feed your model. You have to recognize your model in the plot tree. Just you write plot underscore tree and your model, and you have to add the additional parameters, and also you can press shift tab. Okay, so you also get these values. 1 minute, I just adding the kernel. Is ready, I think that. Okay, so you have to add your model. You have to field that is true, and features name that you have to provide. And then you can see that the Decesion Tree models that on the iris dataset, how it is looks like. So you have that Guinea impurity, you have the petal length, all the things you have seen the Decesion Tree model. So that is pretty important to understand the Decesion Tree model. So that is the reason I have created one iris dataset, and means I have to create my Decesion Tree model on the iris dataset, but the project, the process is same. There is no changes in the process, just taking an example of iris dataset, how it looks like. And now we can you can see, when I already told how we can use the Decesion Tree model and when we have to use the random forest. I already discussed the Decesion Tree model, when we have to use, and now you have to understand how we can use that random forest. Okay, so random forest, you can check, and the improved generalization. So random forests are an ensemble technique, right? Ensemble of Decesion Tree. Please remember, random forests are an ensemble of Decesion Tree, and they are known for better generalization performance. So we have to know the use cases, that whenever we are going to use the Decesion Tree, whenever we are going to use the random forest. So improved generalization, that is one point. So random forests are an ensemble of Decesion Tree, and they are known for better generalization performance. And I also say that they reduce overfitting by combining multiple weak learners into a robust model. So they can try to reduce the overfitting by combining multiple weak learners. So they are some weak learners or means weak trees, right? So they have to edit this tree and they have to combine and into and they have to create the robust model. So improve generalization, that is one point, and I can see the higher accuracy. So in many cases, random forest can provide your higher accuracy compared to a single decision tree. So especially when you are dealing with complex data set, that time you obviously predict the higher accuracy. We exactly predict that higher the value should be accurate, and that is the reason we have used the random forest to improve generalization, higher accuracy. That is one of the case where we can use the random forest and handling missing values. That I already added all the points over here, and I have already shared this notebook to the description box, so you can add all the points and you can understand. So handling missing values. So the random forest can handle, you can say, the missing values in the data set more gracefully than a single decision tree. Okay, and they use a majority vote from different trees to make prediction and reducing the impact of missing data. Okay, and that is one point, that handling missing values, the random forest can handle missing values in the dataset more gracefully than a single decision tree and robustness to outlier. So random forests are generally more robust because it's an ensemble of decision tree model. So random forests are generally more robust to outliers and noise in the data, compared to a single decision tree. These are 4 5 points that I have added, that we have to use that random forest. And one thing we have to remember, that in a practice it's common to start with a decision tree to you have to understand the problem, and then we can explore. So we have to start with the decision tree, and now we have to explore that ensemble methods, like it's an ensemble method like random forest to improve performance. So we have to take a note of the part that if interpretability is crucial and a data set is small, a decision tree might be sufficient. If your interpretability, if you focused on your interpretability, that model, then it is crucial and your data set is small, then you might go to decision tree that is very sufficient for larger and more complex data set where accuracy is priority, where not interpretability, then random forests are often a good choice. Okay, so these notes I have already added. I hope that it may help to understand that decision tree and random forest, whatever that best use cases, whenever I'm going to use that, and that is the reason I have added. Now we move to the random forest model. Okay, so random forest, I already written that random forest ensemble of decision tree, and same kind of tasks they have given, like build a random forest model where dependent variable is your churn and independent variable are tenure and monthly charges. So here two independent variable and one is dependent variable. Let's see how we can do that. Okay, so you can say that I already created this random forest classifier. So you have to import the random forest classifier from sklearn.ensemble. This is that class from where you have to import that random forest classifier. Just go and you can also search random forest classifier. The same way. There is no other changes. Just search random forest random classifier scalar, or you just probably get this first link. Just click over there, and this is the official link of random forest classifier, and you can check that random forest classifier is a meta estimator that fits the number of decision tree classifier on various subsamples on the dataset. So you can explore that official website if you are more interested. So these links I'll add in the description box. So let's move to that problem statement and how we have to solve that. Okay. So you can see scalar.ensemble and you have to import the random forest classifier. And now you have to add this one. Let me check one thing. Uh, Okay, so you have to take, you have to import the random forest classifier and same process that you have to initialize, you have to create an instance of your model. So I have created that random forest classifier, Rx is equal to random forest classifier, and here you can see we have to divide the data set in that is 70 and 30, right? So 70% should be goes to the training data and 30% should goes to the testing data. So I have already created X train, X test, Y train, Y test, and you have to split the data, train, test, split, and you have to pass your X variable, your independent X and Y is target column, right? And your test size that is 30% and random state is 0. So X10, X10, Y10, Y test, and you also see the shape of your data and you have to fit your model. You can fit this model with X10 and Y10. So we already see that I have already created the random forest classifier model and process is same, array.predict, same prediction we have done, and we have to create the confusion matrix. So in order to create the confusion matrix, process is already same. I already told that y test and y pred you have got these values, and also you got the accuracy score that you have to pass that y test and y pred. So I already discussed how we can manually do that the accuracy score. So here we can see the 75% of accuracy score of random forest model, and that is I think from the decision tree also 74 kind of things, and here 75%, and you just export this model. So you just use joblib.dump and your forest name you have to see, and if you go your notebook, then you can see that regression model dot shape, random forest dot joblib, logistic regression model. So every 4 models I have exported for latter use case. So you can also use some API, you can also use that web application, and you can use that models. Okay, so that is the reason I have export, and now I have also test, we have also load like the 2 commands joblib.dump, and you have to export your model, and joblib.load, and you have to load your model. And when you load your model, that time with that loaded model you can also predict that the value is same. So I hope I already covered all the 4 machine learning models over here. So logistic regression, linear regression, decision tree, and random forest. And the main aim of this project I already told, that is to understand that how we can start, and where we can create that process. And in this project, we have already done the data manipulation part. We have already So we have already done the data manipulation part. We have already done the data visualization part, and we also